So let's go ahead and do some example problems here. So the first one here, continuing from our example problems last time. So the sound wave is produced with a frequency of 20 hertz. What is its pitch? Well, we know that the pitch equals the frequency. So the frequency is 20 hertz. That means that the pitch has to be 20 hertz. Moving on. So a sound wave is measured moving at 3 meters per second with a a wavelength of 2 meters. What is the pitch of the sound? Well, once again, we know that pitch is frequency, so all we do is find the frequency. Well, we know last time, we know that wave speed and frequency and wavelength are connected by the equation of the wave speed equals the wavelength times the frequency. The wavelength is 2 meters and the speed is 3 meters per second. I gotta rearrange this equation here to get frequency by itself. So frequency equals wave speed divided by the wavelength, which equals the wave speed was 3 and the wavelength was 2, which equals 1.5 hertz. So the pitch then equals 1.5 hertz. This would be capital H. So once again, all we did is that we know that the pitch is the same as the frequency. We have the wave speed and the wavelength. We use the wave speed equation to relate wave speed, wavelength, and frequency. And we find the frequency, and once we find the frequency, we can use that as our pitch, because the pitch is just the the frequency of the sound wave. Okay, what is the speed of a sound wave that has a frequency of 780 hertz and a wavelength is measured to be 1.5? Well, if we just did something just like this, we want to know the wave speed. Well, we know wave speed is equal to wavelength times frequency. The frequency is 680 and the wavelength is 1.5 meters. Well, I don't gotta do anything about this. I know the wavelength is 1.5. It's right in the form I need it to be in. And then if 1.5 times 680, let's see it, 1.5 times 680 should be, I believe, 1020. So 1020 meters per second. Easy as that. So sound waves are waves, and all waves follow the same equations for wave speed, wavelength times frequency. We have the frequency, and we have the wavelength. If I told you the pitch was 680 hertz, you know that pitch is frequency, so you do the same thing. Alright, number 9. What is the speed of a sound wave with wavelength of 4 meters per second in the period of 2 seconds? Ooh, alright, this is a little different. We gotta go back and think about our relationships. So we know that we're looking for the wave speed, so it's probably best to just write down the equation for wave speed. Wavelength times frequency. Well, I have the wavelength that's given to me. I'm told that the wavelength equals 4 meters. Okay. And the period, which if you remember, we use capital T, is 2 seconds. Well, I know that frequency from my equations from last time. Frequency is given by 1 over the period. And that's a really bad F. I apologize. Anyway, so frequency is 1 over period. Well, 1 over 2 is 0.5 hertz. Alright, so we have the wavelength of 4 meters in a period of 2 seconds. That means the wave speed is given by 4 times 0.5, which is 2 meters per second. Alrighty. So these ones, we're going to see if it's reflection, transmission, or absorption. So you yell in the cave and you hear an echo. Well, echoes occur when a sound wave travels back to you, right? Because you hear it back. So it hits something and comes back. Well, if it hits something and comes back, to me that sounds a lot like reflection. A soundproof room presents sound from being heard through the walls. Well, if the walls don't let the sound get through, it's something like it absorbs it. So I'm going to say let's go ahead and call that a absorption. Light in the form of wave shines through a window. Well, keyword here is through. We're shining through something. Something is traveling through something. When something goes in and comes out the other side or through, we know that is indeed transmission. Then light in the form of wave hits a mirror and bounces off. Well, I would say that is, we're talking about bouncing off, I would say that is indeed reflection. Okay, only a couple more problems here to go. So determine if the wave gets bigger or smaller given the following examples. So the crest of the first wave meets the crest of the second wave. So the two waves here, when a crest meets a crest, we know that is constructive, so it has to get bigger. The crest of the first wave meets the trough of the second wave. Well, when a crest meets a trough, we know that's going to be smaller because that's deconstructive interference. Okay, let's determine if it's going to be constructive or deconstructive here. Alright, so the first one here, we have this trough lines up, this crest lines up with a crest. This crest lines up with a crest. I'm seeing crest lining up with a crest. So crest to crest, that's going to be constructive. Alright, now let's go ahead and do the next one. Well, got a crest here lining up with the trough of a second wave. So the crest and trough, crest and trough, crest and trough. So that looks like it's going to be deconstructive. Alright, last but not least is this one here. Now the waves don't line up perfectly, but that's not what we're looking at. We're looking at crest to crest or crest to trough. So going here, let's go back here and let's see what lines up with. Well, it looks like this is a crest to crest. Looks like this is a crest to crest. And it looks like it's a crest to crest. So it lines up crest to crest. So that's going to be indeed constructive. Alright, so 13, find the resultant amplitude of the following. So we have a wave, A has amplitude of 4 meters, and constructively interferes with a wave that has amplitude of 2 meters. Well, constructive means they add up, so amplitude of 4 meters, amplitude of 2 meters. This is simply 4 plus 2 equals negative, oh, not negative 2, wow, 6. I was reading the problem down there. Alright, then wave A has amplitude and deconstructively interferes with wave B that has amplitude negative 2 meters. Well, let's see what happens here. We're going to add them up. So its amplitude is 2 meters, and this is negative 2 meters. So 2 plus negative 2 equals 0 meters. So that gets smaller. So it deconstructs. Alright, so that's it for the example problems. Hopefully this helps. If not, feel free to look at the notes again or send me an email.